Welcome to Module 8. Module 8 is basically all about correlation coefficient. And in order to proceed, you should have the data analysis tool pack loaded into your computer. So if you do not have it, follow these directions to get the tool pack loaded to your Excel. So let's look at correlation coefficient. If you look at the lecture notes, finding the correlation coefficient is rather complicated. The formula is very, very tedious. Luckily, we're going to be doing all the work in Excel, and I'll show you how to figure out the correlation coefficient, R, and the value of R squared. And also, we're going to determine whether there's sufficient evidence to support the correlation between, in this case, the weight of the car and the braking distance at alpha is 0.05. So, we want to know if there's a correlation between the weight of the car and then braking distance of that car. So, in order to find the correlation coefficient, the function name is CORREL. So here's how you do it. Equal sign, correl. And basically select one column, comma, click on the second column, and close parentheses. You notice that it's B9 to B40 and then C9 to C40. So the 9 and 40 should match. Only difference should be the letters. Otherwise, you get an error. So if you get an error here, you probably don't have the matching numbers here. So press enter, and you get correlation. To get the R squared value, basically you just square this number. So click equal sign, click on the cell, and square it. And this number, R squared, is also known as a coefficient of determination. So if you're asked to figure out the R squared or coefficient of determination, you first figure out the correlation coefficient and just simply square it. And to answer the question, is there sufficient evidence to support the correlation between the weight of the car and the braking distance? What you need is the critical value of R for when n is 32. So there are 32 cars here. And I gave you the table here, which is also the table A6 in the book, all the value of the critical values for R. So here's a column for alpha is 0.05 and alpha is 0.01, and we're going to use the column from 0.05 because of what the problem said. And since there are 32 cards, and we don't have an exact entry for 32, we're going to use the closest value, which is 30. So the critical value for n is 30, for alpha is 0.05, just intersection of those two things, is 0.361. So let's remember that. 0.361. What you do is make the correlation coefficient and the critical value, the signs the same. So basically just make it a both positive numbers. So positive 0.0867 versus 0.361. Okay. The rule is, since the correlation coefficient, the positive value 0.0867 is less than 0.361, we conclude there's not sufficient evidence to support the correlation between the weight of the car and the braking distance. So it seems to me, or it seems to us, that based on the data, there's no correlation between the weight of the car and the braking distance. Some of the things you'll be asked to reproduce is the scatter plot. So I'll show you how to do that. So go to Insert and Chart, and you'd see there's a Insert Scatter button. Click on that and pick the very first one. Oops. Backwards. Select those values first, and then go to Insert and click on Scatter Plot. Okay, so here's initial one. And we want it to look like this. So you notice that nothing starts until about 2500. So we want to adjust, clear out these values here. So how do we do that? Double click on it. And you see that it's 0 to 5000. So change this to 2000, say. Tab, and it'll change to look like this. You can do whatever you want, 2100, 2200, just eyeball it. You could even make it 2500. Okay. Double click on the break-in and then change it to, say, scatter plot, since we're doing scatter plot. Okay. And then how do you get this line, y value, and r square? Just click on it, double click on those numbers, one of those dots, and right click on it, add trend line. It'll add the dotted line here, and it should be linear. It should be the default, so you should have to do anything. And to get the r square value, you notice the display r square value on the chart, so just click on that. And since you're there, just click on the display equation for chart on chart. You'll be using that a little bit later in a later module, so module will learn how to do those. So it should be linear, equation on chart, and r square on chart. Close this and just move around r square value and then equations, and then you're set. Okay. So how do we do this hypothesis testing for correlation using p-value method? Here's an example from the lecture notes. Shear print versus the height. So the x represents the shear prints and y represent the height. We want to know if there's a correlation between these two things, shear print and the height. Now hypothesis, no, there's no correlation. And if the correlation, this value is not 0, that means there's a correlation. In this character here, it looks like a P, but it's actually pronounced rho, Greek letter for R, so rho. And so when the rho is 0, there's no linear correlation. When the rho is not 0, there is a correlation. So, and in this case, we set the degrees of freedom to be n minus 1. Using this information and this formula here, we figure out the t-value, test statistic, and put that into the usual two-tail test, because we're saying not equal to. And so you use t.this, that 2t function, to get the p-value of 0.29. You notice the p-value is greater than the significance level 0.05. We failed to reject the null hypothesis. That means we're going to go with there's no linear correlation. So we conclude that there's not sufficient evidence to support the claim of a linear correlation between the shear print length and the heights. So rho of 0 means no correlation. So in order to test that, here's one way to show the one-tailed test. If it's a negative correlation, the alternative is that the rho is less than 0. If it's a claim of a positive correlation, then you set the alternative and then rho to be greater than 0. And that's it for correlation coefficient.